Good day, grade 11 students. Welcome to another learning session in General Mathematics. I am Miss Mayrel C. Bayotas and I will be your teacher for today. Now we're going to discuss Lesson 3 of Quarter 2 entitled Simple and General Annuity. It is actually the continuation of the topic last week, which is compound interest. Before we start the discussion, let's all look at our objectives. At the end of the lesson, you should be able to, number 1, illustrate simple and general annuities. Number 2, distinguish between simple and general annuities. And number 3, find the future value and present value of both simple and general annuities. Let's get started. We'll play the game called Decode Loop. Here, every digit corresponds to a letter or letters. You will be given a set of numbers which you will decode to form words related to our topic, annuity. Kindly type your answers in our comment section. Let's see how good you are on this. Let's decode the first word. We have the digits 6, 1, 0, and 3. Remember that it corresponds to the letters R, A, M, T, and E. The correct word is rate. Did you get the correct answer? Nice start! Let's see how you do on the next one. We have the digits 5, 8, 0, 3, 6, 9, 1, and 9. Here are the corresponding letters. The right word is interval. Good job! Let's decode the third word. We have the digits 7, 1, 2, 1, 3, 8, and 0. The corresponding letters are flashed on screen. The word that we are looking for is payment. Nice work! We have the digits 1, 8, 8, 5, 5, 0, and 2. Here are the corresponding letters to guide you. The correct word is annuity. Now we're down to the last one. We have the digits 8, 5, 0, 5, 6, and 3 for the first word, and 9, 1, 9, 5, and 3 for the second word. Look at the corresponding letters closely. The exact phrase is future value. You all did well. 2 thumbs up for that. At this point, let us define important terms in this lesson. Let's have first annuity. Annuity is a series of payments made at equal or fixed intervals or periods of time. Example of annuity is installment basis of paying a car, appliance, house and lot, tuition, etc. Can you think of other examples? You may type it in the comment section. Next is payment interval. It is a time between successive payments. Now, let's define term of annuity. It is usually represented by small letter d. Regular periodic payment, written as capital letter R in the formula. It is the amount of each payment. Amount or future value of an annuity, or capital letter F, is the sum of future values of all the payments to be made during the entire term of the annuity. Present value of an annuity, or capital letter P, is the sum of present values of all the payments to be made during the entire term of annuity. There are different types of annuities which may be classified according to payment interval and interest period, namely simple annuity and general annuity. Other types are classified according to time of payment, namely ordinary annuity or annuity immediate and annuity due. Lastly, according to duration, namely annuity certain and contingent annuity. Let's get to know them one by one. Again, the first two are classified according to payment interval and interest period. Simple annuity is an annuity where the payment interval is the same as the interest period. General annuity is an annuity where the payment interval is not the same as the interest period. Let's see if you understand the definition clearly. Kindly type general annuity if you think the given suggests so. Otherwise, write simple annuity. Payments are made at the end of each month for a loan that charges 1.05% interest compounded quarterly. Go ahead and type your answer. The correct answer is general annuity, since the payment interval is monthly or 12 times a year, while the interest period is quarterly or 4 times a year. In other words, they are not the same. Here's another example. A deposit of 5,500 pesos was made at the end of every 3 months to an account that earns 5.6% interest compounded quarterly. Don't be shy to comment your answer. If you answered simple annuity, you are right. If you observe closely, the payment was made 4 times a year since it is done every 3 months. The same goes for the interest period, which is quarterly. Since they are the same, it is an example of simple annuity. The next two are classified according to time of payment. Annuity immediate or ordinary annuity is a type of annuity in which the payments are made at the end of each payment interval. Annuity due is a type of annuity in which the payments are made at the beginning of each payment interval. Now, let's try another set of examples. Just like what you did earlier, simply type your answer in the comment section. This time, you may choose between annuity immediate and annuity due. June's monthly mortgage payment is 35,148.05 pesos at the end of each month. The correct answer is annuity immediate, since he makes his payment at the end of each month. Let's try the next one. The rent of the apartment is 7,000 pesos and due at the beginning of each month. Comment your answer. Did you type annuity due? Wow, you get it right again. That is because the payment is made at the beginning of each month. And the last two are classified according to duration. Annuity certain is an annuity in which payments begin and end at definite times. Contingent annuity is an annuity in which the payments extend over an indefinite or indeterminate length of time. Examples of contingent annuity are life insurance and pension payments. Alright, before we dig in deeper in this topic, let's recall. How are annuities categorized again? Correct! Annuities are classified according to payment interval and interest period, according to time of payment, and according to duration. Can you differentiate between simple annuity and general annuity? Good job! In simple annuity, payment interval is the same as the interest period, while in general annuity, it's not. How about annuity immediate and annuity due? You're right! In ordinary annuity, payments are made at the end of each payment interval, while in annuity due, it is made at the beginning. Of course, let's not forget annuity certain and contingent annuity. How do they differ? Well said. In annuity certain, payments begin and end at definite times, while in contingent annuity, it extends over an indefinite length of time. Let's try to solve word problems to understand annuity better. Sample problem number 1. Suppose Mrs. Remoto would like to save 3,000 pesos every month in a fund that gives 9% compounded monthly. How much is the amount or future value of her savings after 6 months? We may find the future value using the following steps. Step 1. Illustrate the cash flow in a time diagram. It is similar to a number line. We start with 0 and end with 6 since term or T is equal to 6. At the top, we write 3,000 pesos for each month since Mrs. Remoto's periodic payment or R is equal to 3,000 pesos. Step 2. Find the future value of all the payments at the end of the term or T equals 6. Using the tree diagram that shows the cash flow, we start by putting 3,000 pesos at 6 or the 6th month. Next, put 3,000 pesos times 1 plus 0.0075 at 5 or the 5th month. Recall that this formula was discussed in compound interest, and 0.0075 is the value of J based on the given. After that, put 3,000 pesos times the quantity of 1 plus 0.0075 squared. Again, that is because we follow the rule of compound interest. Looking at the illustration, notice that the exponent increases up to 5, which is placed at 1, or the first month. Step 3. Add all the future values obtained from the previous step. That is 3,000 pesos plus 3,022.50 pesos plus 3,045.169 pesos plus 3,068.008 pesos plus 3,091.018 pesos plus 3,114.20 pesos. Thus, the amount of this annuity, or F, is 18,340.89 pesos. Do not forget to put peso sign in your final answer. Did you follow from step 1 to 3? Wow! You're as patient and attentive as expected. Actually, there's another way of solving for the future value. That is through the use of the formula F is equal to R times the quantity of 1 plus J raised to N minus 1 all over J, where R is the regular payment, J is the interest rate per period, and N is the number of payments. This formula was derived based on the procedure on how to accumulate the payment of each period to the end of the term. After reading the problem carefully, let us now list down the given. Since Mrs. Remoto would like to save 3,000 pesos every month, that will be her periodic payment, or R is equal to 3,000 pesos. Since the savings will be completed in 6 months, this will also be the term, or T equals 6 months, or 1/2 year. Since the given rate is 9%, the interest rate per annum, or per year, is 0.09. We converted 9% to decimal by simply dividing it by 100, or by moving the decimal point 2 places to the left. And since the fund will be compounded monthly, the number of conversions per year is M equals 12. That is because there are 12 months in a year. To get the number of payments, N, we multiply time and number of conversions per year. We have 1/2 times 12 equals 6. Finally, to get the interest rate period, we use the formula J equals I over M. By substitution, J equals 0.09 over 12. Therefore, J equals 0.0075. First, substitute the given to the formula. We have F equals 3,000 times the quantity of 1 plus 0.0075 raised to 6 minus 1 all over 0.0075. Following PEMDAS, begin by simplifying what's inside the parentheses. That is, F equals 3,000 times the quantity of 1.0075 raised to 6 minus 1 all over 0.0075. Then, simplify. 1.0075 raised to 6. Now we have F equals 3,000 times 1.04585222351 minus 1 all over 0.0075. Notice that we did not round off yet so that we can arrive at a more accurate answer. It is actually good if you key in all the entries in your scientific calculator at once. Just make sure to type them accurately. Alright, next, we subtract 1. That is, F equals 3,000 times 0.04585222351 divided by 0.0075. Then, divide 0.04585222351 by 0.0075. That makes F equals 3,000 times 6.1136313467, resulting to F equals 18,340.89. We arrive at the same result. Thus, the amount of this annuity is 18,340.89 pesos. Again, do not forget to put peso sign in your final answer. By the way, here's how the solution will look once you encode it in your scientific calculator. Sample problem number 2. In order to save for her high school graduation, Marie decided to save 200 pesos at the end of each month. If the bank pays 0.25% compounded monthly, how much will her money be at the end of 6 years? By the way, I hope every one of you applies your knowledge about annuities in managing your finances for school-related concerns, just like how Marie planned to save money for her school graduation. Make sure to read and analyze the problem carefully before writing down the given. Since Marie decided to save 200 pesos at the end of each month, her periodic payment, or R, equals 200 pesos. Since she will be saving money for 6 years, this will also be the term, or T, equals 6 years. Since the given rate is 0.25%, the interest rate per annum or per year is 0.0025. We converted 0.25% to decimal by simply dividing it by 100 or by moving the decimal point 2 places to the left. Since the amount is compounded monthly, the number of conversions per year is M equals 12. And since it will be done consistently for 6 years, the number of payments is M equals T times M. That is, term times the number of conversions per year. N equals 6 times 12, which is 72. Finally, to get the interest rate period, we use the formula J equals I over M. By substitution, J equals 0.0025 over 12. Therefore, J equals 0.0002083. The vinculum means that the value is a repeating, non-terminating decimal at 3. This time, we won't be going through steps 1 to 3 since we already learned the formula in problem number 1. That is, F equals R times the quantity of 1 plus J raised to N minus 1 all over J. Just like what we did in the first problem, substitute the given to the formula first. We have F equals 200 times the quantity of 1 plus 0.0002083 raised to 72 minus 1 all over 0.0002083. Again, following PEMDAS, let's start by simplifying what's inside the parentheses. That is, F equals 200 times the quantity of 1.0002083 raised to 72 minus 1 all over 0.0002083. Then, simplify 1.0002083 raised to 72. Again, it can be more practical and accurate if we key in all the entries in your scientific calculator at once, especially in cases like this wherein the exponent is very high. But to show the step-by-step procedure, let us continue. Now we have F equals 200 times the quantity of 1.015109043 minus 1 all over 0.0002083. Then subtract 1. That gives us F equals 200 times 0.01510943 divided by 0.0002083. That makes F equals 200 times 72.5350120019, resulting to F equals 14,507. Therefore, Marie will be able to save 14,507 pesos for her graduation. Again, let me show you how the solution will look like once you encode it in your scientific calculator. Let's proceed to sample problem number 3. Rose works very hard because she wants to have enough money in her retirement account when she reaches the age 60. She wants to withdraw 36,000 pesos every 3 months for 20 years after she retires. How much must Rose deposit in her retirement account at 12% per year compounded quarterly for the annuity? What can you say about the problem? That's true. As smart students, you may influence others on how to assure that their hard works will not go in vain, just like how Rose saved money using her retirement account. Now, do you think it's the same with sample problems number 1 and number 2? Good observations. This problem asks us to compute for the present value. We can derive the formula for present value from the formula we used earlier. The present value P of an ordinary annuity is given by P equals R times 1 minus the quantity of 1 plus j raised to negative n all over j, where R is the regular payment, j is the interest rate per period, and n is the number of payments. Read and analyze the problem carefully so that you can identify the given accurately. Rose would like to withdraw 36,000 pesos every 3 months, meaning her periodic payment R is equal to 36,000 pesos. Since she will be doing this for 20 years, this will also be the term, or T is equal to 20 years. Since the account will gain 12% interest, I equals 0.12. Remember, we convert percent to decimal. The number of conversions per year, or M, is 4. Since earlier, we learned that saying every 3 months is the same as the word quarterly. Since the money will be compounded quarterly for 20 years, the number of payments is N equals TM. N equals 20 times 4 equals 80. Finally, to get the interest rate period, we use the formula J equals I over M. By substitution, J equals 0.12 divided by 4. Therefore, J equals 0.03. Okay, so we'll start with substituting the given to the formula. We have P equals 36,000 times 1 minus the quantity of 1 plus 0.03 raised to negative 80 all over 0.03. Considering Pendle's rule, simplify what's inside the parentheses. That is, P equals 36,000 times 1 minus 1.03 raised to negative 80 all over 0.03. Now we have P equals 36,000 times 1 minus 0.093977096 over 0.03. Subtract. We'll have P equals 36,000 times 0.906022903 over 0.03. Divide. P equals 36,000 times 30.20076,345. Lastly, multiply, and that will be P equals 1,087,227.48. Notice that we did division first before multiplication. If you do it the other way around, say you multiply 36,000 by 0.906022903, then divide it by 0.03, you get the same answer. Hence, Rose must deposit 1,087,227.48 pesos. Take a look at the solution using scientific calculator. Now here's the fourth example. Mr. Ribaya paid 200,000 pesos as down payment for a car. The remaining amount will be settled by paying 16,200 pesos at the end of each month for 5 years. If interest is 10.5% compounded monthly, what is the cash price of his car? What is being asked in the problem? Correct. We are asked to compute for the cash price of the car. By the way, cash price is also called cash value. Good job! We will use the formula for cash value. That is, cash value or CV. CV is equal to DP plus P, where DP is the down payment and P is the present value. Let's list down the given. Mr. Ribaya paid 200,000 pesos as down payment for a car. So we write DP equals 200,000 pesos. To settle the remaining balance, the periodic payment is R equals 16,200 pesos. This will be paid for 5 years, meaning T equals 5 years. The interest, 10.5%, is converted to decimal. So we have I equals 0.105. Since the payment will be made monthly, M equals 12. The number of payments is 5, which is time multiplied by 12, which is the number of conversions per year. Lastly, J equals 0.105 over 12 equals 0.00875. This time, we'll compute first for the present value. Using the formula P equals R times 1 minus the quantity of 1 plus j raised to negative n all over j. Let's substitute. We have P equals 16,200 times 1 minus the quantity of 1 plus 0.00875 raised to negative 60 all over 0.00875. Next, add 1 and 0.00875. P equals 16,200 times 1 minus 1.00875 raised to negative 60 all over 0.00875. Then, simplify the term with the exponent. P equals 16,200 times 1 minus 0.5929077762 over 0.00875. Subtract 1 and 0.5929077762. P is equal to 16,200 times 0.4070922237 over 0.00875. Divide 0.4070922237 over 0.00875. P equals 16,200 times 46.52482716. And finally, multiply. P equals 753,702.20. The present value is 753,702.20 pesos. But take note that this is not yet the final answer, since what we are looking for is the cash value. Just like what we did earlier, we can solve this quickly using scientific calculator. Here's how the solution will look like. Recall that the present value computed is 753,702.20 pesos and the down payment is 200,000 pesos. Applying the formula, CV equals DP plus P. By substitution, CV equals 200,000 plus 753,702.20. By adding, CV equals 953,702.20. Alright, let's solve sample problem number 5. Paulo borrowed 100,000 pesos. He agrees to pay the principal amount plus interest by paying an equal amount of money each year for 3 years. What should be his annual payment if interest is 8% compounded annually? Can you figure out what is being asked in the problem? Nice one! Here, we are looking for the periodic payment or regular payment R. Since one of the given data is the present value, we can derive the formula for regular payment from the formula for present value. To derive, we write first the formula for present value. P equals R times 1 minus the quantity of 1 plus j raised to negative n all over j. Then, using multiplication property of equality, we multiply both sides by the quantity of 1 over 1 minus the quantity of 1 plus j raised to negative n all over j to cancel 1 minus the quantity of 1 plus j raised to negative n all over j. That is, P times the quantity of 1 over 1 minus the quantity of 1 plus j raised to negative n all over j equals R times the quantity of 1 minus the quantity of 1 plus j raised to negative n all over j times 1 over 1 minus the quantity of 1 plus j raised to negative n all over j. Simplify, P times 1 over 1 minus the quantity of 1 plus j raised to negative n all over j equals R. Or R equals P over 1 minus the quantity of 1 plus j raised to negative n all over j. The regular payment R of an ordinary annuity is given by the formula R equals P over 1 minus the quantity of 1 plus j raised to negative n all over j, where P is the present value, j is the interest rate per period, and n is the number of payments. Now let's write all the given. Since Paolo borrowed 100,000 pesos, that will be P equals 100,000. He agrees to pay it for 3 years, meaning T equals 3. The payment interest is 8%, that is I equals 0.08. Since it will be compounded annually or once a year, the number of conversions per year is M equals 1. The number of payments, N, is T times M. That is, 3 times 1 equals 3 periods. Lastly, the interest rate per period is rate divided by number of conversions. That is, J equals 0.08 divided by 1 equals 0.08. Here's the solution. By substitution, R equals 100,000 over 1 minus the quantity of 1 plus 0.08 raised to negative 3 all over 0.08. Following PEMDAS, we begin by simplifying the operation inside the parentheses. R equals 100,000 over 1 minus 1.08 raised to negative 3 all over 0.08. Next, simplify the term with exponent. R equals 100,000 over 1 minus 0.793832241 all over 0.08. Notice that the denominator is more complicated than the numerator 100,000. So let's focus first in the denominator. Subtract 0.793832241 from 1. R equals 100,000 over 0.206167759 over 0.08. Then divide 0.206167759 over 0.08. R equals 100,000 divided by 2.577096987. Lastly, divide the numerator by the result in the denominator. The final answer is R equals 38,803.35. Hence, Paolo's annual payment should be 38,803.35 pesos. Let's see how it will look like using scientific calculator. Here's the last sample problem for today. Mr. Ribaya would like to save 500,000 pesos for his son's college education. How much should he deposit in a savings account every 6 months for 12 years if interest is 1% compounded semi-annually? Can you compare problem number 5 and problem number 6? Very good. For both problems, we are asked to solve for the regular payment, R. But what do you think is the difference between the two? Correct. Here, we are going to solve for r given the future value. Let's have a look at the formula for periodic or regular payment given the future value. The regular payment r of an ordinary annuity is given by r equals f over the quantity of 1 plus j raised to n minus 1 all over j, where f is the future value, j is the interest rate per period, and n is the number of payments. First, let's list down the given. Since Mr. Ribaya would like to save 500,000 pesos, the future amount is f equals 500,000. The savings account is set for 12 years. Thus, T equals 12. The given interest is 1%, that is, I equals 0.01. Since it will be compounded semi-annually or twice a year, the number of conversions per year is M equals 2. The number of payments is 12 times 2 equals 24 periods. Lastly, the interest rate per period is J equals 0.01 divided by 2 equals 0.005. Let's substitute the given to the formula. R equals 500,000 over the quantity of 1 plus 0.005 raised to 24 minus 1 all over 0.005. Considering PEMDAS, add 1 and 0.005 which are inside the parentheses. R equals 500,000 over the quantity of 1.005 raised to 24 minus 1 all over 0.005. Then, simplify the term with exponent. R equals 500,000 over 1.127159776 minus 1 all over 0.005. Just like what we did earlier, let's focus first in the denominator. Subtract. We'll have R equals 500,000 over 0.127159776 over 0.005. Divide. R equals 500,000 over 25.43195524. Lastly, divide the numerator by the result in the denominator. The final answer is R equals 90,660.31. Here's how the solution will look like once you encode it in your scientific calculator. Well done, grade 11 students! Here's our takeaway for today. Make sure that aside from understanding the key terms in annuities, you also know the different formulas that can be used depending on the situation. Of course, do not forget the procedures that we applied in each sample problem earlier. For today's assignment, kindly answer assessment items number 1, 2, and 3 on page 8 of your self-learning module. For questions and clarifications, please make sure to attend your follow-up discussion with your mathematics teacher. Thank you for listening and participating in this session. Again, this has been Ms. Mayrel C. Bayotas, your General Mathematics live streaming teacher for today, leaving you with the words, "The hardest arithmetic to master is that which enables us to count our blessings," by Eric Hoffer. Let's always appreciate the blessings around us. God bless us.